Happy Tuesday, everyone. Welcome to today's webinar. I'm Lori DeToro, Editor-in-Chief of Equipment Today. I'm excited to be moderating Top 5 Tips to Maintain Your Construction Equipment Tires, sponsored by Maxim Tire. This webinar will share helpful tips for maintaining tires on construction equipment such as skid steers, backhoes, and front wheel loaders. In addition to picking the right tire size and selecting a certain tread design, contractors should consider other factors that will be covered in today's presentation. Before we get started, I'd like to cover a few housekeeping notes. The displays during this webinar are fully customizable. You can make the video player larger or the slides larger to view them easier. It's your system to set up however you like. We also ask that you find the Q&A section. We encourage you to ask questions throughout the webinar, beginning now. If you have a question, type it into this section and we will answer as many as possible as time allows. Also, check out the related content section. The Maxim Tire team has shared more information, including a podcast, the presentation slides, and other great content. Please be sure to check that out. Also, this webinar is being recorded and will be available on demand after today's live event. Also, like we just said, this is a live event. So when we mess up, and we probably will, forgive us and laugh along with us. Now I'd like to introduce our presenter. Michael Vandal, Regional Sales Manager of Maxim Tire North America, is going to be talking with us today. And we are super happy to have him. Michael, let's get started and tell us a little bit more about yourself.
Well, Lori, thank you for having Maxim Tire. Folks, my name is Michael Vandal. I am the Regional Sales Manager for the Rocky Mountain region for Maxim Tire. My states of responsibility include Wyoming, Colorado, New Mexico, and Kansas. Just want to thank you for joining us today and let you know that if you have a burning question you've been wanting to ask about Maxim or something in your past or something you're dealing with right now, now's a great time to do that. Go ahead and go to the Q&A section, type it out, and we'll try and cover that as quickly as we possibly can. And if there's not one, we can go ahead and get started with the 5 tips to maintain your construction equipment tires. So any questions out there?
Michael, not yet. I think we're probably gonna wait until you get started with your presentation. I'm sure we'll get questions as we go, and I'll hop in and ask them whenever you're ready for them.
Great, thank you. And my little button is not working. Let me see if I can fix that. My keyboard shortcuts, and there we go. All right. So, a few things we're going to cover today, besides questions, is why tire maintenance? Why is that important? How is it going to affect your day-to-day business? The importance of air pressure. Why do you need to check it? When do you need to check it? Picking the right application. Sometimes we don't really need a tire. Sometimes we need a different tread design. Seasonal maintenance and common breakdowns. How to avoid some of these things and how to check for them before we go into the season. How to extend tire life and conduct a proper pre-shift check. And then at the very end, we're going to have some summary and questions. So tire maintenance. A lot of it's about the bottom line, but the biggest part is safety of the operation and safety of the operator. So yeah, we want to minimize repair costs. We want to improve tire life. We want to maximize productivity. We want to minimize downtime. And we want to potentially reduce fuel consumption. However, all of those things go back to the operator and their safe operation of that machine. We don't want a catastrophic failure while we're carrying a load on a skid steer, a backhoe, or a front end loader. And we certainly don't want a catastrophic failure while we're going down the road from job site to job site. So tire maintenance is key to keeping our operators and our operations safe. So a little bit about air pressure. What a lot of folks don't know is for every 1 degree drop in, sorry, not 1 degree, for every 10 degree drop in Fahrenheit, you get a 1 psi drop in your tire pressure. So depending on the size of your tire and your load, that can be dramatic. If you're looking at a skid steer tire, drop of 5 psi is 10% load reduction. And that can mean the difference between tire failure and the tire being able to live out its life. It can also mean the difference between being able to carry the load safely and not carry the load safely. So if we continue to have our tires lose pressure, we're putting our operators and our operation in an unsafe situation. So the very first thing we want to do is make sure we're checking our tire pressure when the tire's cold. So lowest temperature of the day, usually right before shift starts in the morning. The machine's been sitting overnight. We don't have any operation. We've got to check our fuel levels. We got to check our grease levels. We've got to check our hydraulic oil. We've got to check our motor oil. It's a great time to check the tires and the valve stems and the air pressure. The reason why we do it cold is because every time we work that tire, our air pressure increases because of heat. So you don't want to check it at 2 o'clock in the afternoon unless you're in Saskatchewan and it's February. Then you probably still have a cold tire. But down here in Colorado, New Mexico, 2 o'clock in the afternoon in July, we're going to have a hot tire. And that's going to give us a very bad outlook of our air pressure. It's going to be too high. And if we remove that air pressure from that tire, the next morning we're going to be too low. And that's where we're going to start having problems. So low air pressure means a few things. The biggest thing is damage to the sidewall, the bead, and the lining of the tire. And again, to our operation and the operator that's moving that machine and moving that material. Is there any questions on inflation pressure and when to check it?
Not at this time.
So failure to maintain. Number one, excessive wear. We are going to wear that tire out and it's not going to give us the life that we paid for. Number two, tire component separation. This is something we see a lot of in the industry. When a tire starts building up heat, that's when we start returning to the temperature that it was manufactured. When you do that, the belt package underneath the tread, some of the turn-ups where the bead and the sidewall come together may start separating. Once you have a separation, you're going to have a tire failure, and we want to avoid that, not only for the cost of the tire, but for productivity of our operation. Tire rim slip. Very simple. Too low a pressure, we're going to slip that tire on the rim, we're going to tear apart the bead, and we're going to ruin the tire. And lastly, is where it comes down to is just reduced tire life and loss of productivity. Every hour we're down in an operation costs the operation, and we don't want that. We want to have as much uptime as possible, keeping our people safe and getting the job done as quickly as possible in an efficient manner. So now we're going to talk about the air's ability to carry the load. When we're talking about a radial tire, 80 to 90% of the load is actually carried by the air pressure. It's not carried by the machine. It's not carried by the tire. It's not carried by the rim. It's carried by the air pressure. And that air pressure, the chamber, is actually at the top of the tire. Hence, you have flex at the bottom and you have a very rigid tire up top. So when you're looking at that tire, those radial casing plies are actually stretching at the top to help you carry that load. So you want to match your air inflation pressure with the load that you're going to carry. So anytime you have a chance to put something on a scale and weigh what you're doing is a big advantage when it comes to air pressure and tire life, and most importantly, operator safety. We want to make sure that we're running the right air pressure, not too much. I've got a neighbor, he's fantastic. His wife is she's hard on tires. So every time he pulls into the yard, he runs over with an air chuck and starts putting air in the tires. And I've looked at him, I go, what are you doing? This doesn't make any sense. Well, I've got to have a lot of air pressure because she hits stuff. Like, well, you got a radial tire and you got to have a little bit of flexibility. You've got to have the right air pressure for what they're doing. He doesn't want to believe me. He goes through tires about every 3 years. I just let him. I no longer have the conversation. But when it comes to an operation on a skid steer, a loader, a backhoe, We could weigh those things and we could set the air pressure for the job that we're doing. This is going to improve the ride, allow us to carry it safely, allow the tire to have the maximum amount of life, and allow the operation to have the most amount of flexibility and most amount of opportunity to get the job done right. So the next question we're going to cover is, how do we figure that out? How do we go through the data? Every tire's got this on it. When you're looking at the sidewall, and in particular, this is an MS 907 skid steer tire. It's a 10/16/5, and it's got a load inflation index or a load index, and it's got a speed index. So in particular, this one has an A2. That means it's a 5-mile-an-hour tire. So if you go over 5 miles an hour, tire's not really designed to do that. If you're under 5 miles an hour, you're okay. But you want to match the speed that you're traveling with the load that you're traveling with at the air pressure you're traveling with. So let's say, for example, we look up this tire, and I'll just show you in our book, because all of this at Maxim Tire is public information. You can go to maximtire.com and get it. But every tire that we manufacture has at least a 3-digit load index, whether it be a 136 to a 218. It's going to have an A2, an A5, a B, an A8. All of those are your miles per hour. So match the data with the tire, with the air pressure, with the load, with the machine. Make sure that you're not exceeding those speed parameters, and make sure you're not exceeding those load parameters and inflation parameters. Any questions on that?
We do have one, and it kind of goes back to something in the introduction as well. Are there differences in building a skid steer tire versus a backhoe tire?
So there's differences in design. I'm sorry?
Talking about that equipment right now.
So there's differences in design, but there's really not differences in how these tires are built. I mean, you start with your casing, you add your beads, you bring your casing and turn up together, you start adding your radial belts on a radial tire, you add your tread face, that goes into the design of the tire and the tread. So how it's manufactured is one thing, the design of it is usually another, and the design of it can be proprietary depending on what we're talking about. Any other questions?
Not at this time.
Okay. Just remember, folks, manufacturers provide the speed symbol, the load index, the inflation tables for all of their products. If it's not a Maxim product, please go out, talk to your tire professional, and make sure you're getting the right information. It's not just 60 PSI. It's not just 80 PSI. It's 80 PSI for a load. Again, if you look at this, at 35 PSI at 5 miles an hour, that tire can carry 3,000 pounds. So here's a great example of matching your load with your speed. So in this particular example, we're doing 30 miles an hour with our machine carrying a load. Our tire inflation pressure is 40 PSI. As we've increased the speed, our load carrying capability has gone down to 3,100 pounds. As we slow down and we go back down to that 5 mile an hour range that we need to at the same pressure, now we can carry 11,700. So this is one of those times where the speed of the operation is very, very imperative to how that tire is going to perform and for the safety of the operator. I know plenty of quarries out there, plenty of operations where we've got the one person in the loader that decides full speed's always good. Well, full speed builds up heat. And if we don't have the right pressure for the heat that we're trying to travel with, we always are going to have a tire failure, no matter what we do. So if our tire is rated for 5 miles an hour, go 5 miles an hour. So I just saw a really great question that was asked, which was, do you recommend using tire tracking software? Absolutely. Track your tires for performance. It doesn't have to be a tire package that you buy. It could be a simple Excel sheet, but start looking at what that tire is doing, the position on the machine, the pressure that you're setting it at. And that's good for the operator to know too. Look at the tread life. How's it doing? Check that out. Once you figure out what tire works best for you with your tracking software, you'll be able to repurchase that tire and continue down the merry path that you are with your productivity and your safety of your operator. If you're not tracking your tires, you'll never know. So yes, absolutely, track those tires. Make sure I got that right. There we go. So any questions on inflation pressure, load indexes, speed recommendations, anything like that before we move on to picking the right tire for the application?
I don't see any other questions right now, so I think we're ready to move on.
Okay. So the questions we've got to ask when we're picking the right tire is machine type. Do I have a skid steer? Do I have a backhoe loader? Do I have a telehandler? Do I have a loader? What am I going to be putting this tire on? Then what's it going to be doing? Am I going to be in softer soils? Will I be moving rock? Will I be moving trees? Will I be moving pallets? What exactly am I going to be doing? Am I going to be on a very hard surface like asphalt or concrete most of the time? From there, now we come down to the compromises. What am I going to be doing the majority of the time? Because no machine sits there and does the same thing day to day to day to day to day. It will travel, it will move, especially when you're talking about skid steers, telehandlers, backhoe loaders. Those machines are designed to do a variety of different things. So once we've looked at all that, now we have to come down to what is my best compromise? And it's all going to be a compromise. There is no one thing that's going to fit the job absolutely perfectly. So let's look at this backhoe loader. In this scenario, main job is going to be softer soils. They're going to use the buckets to be doing cleaning up. They're going to be using the backhoe portion to dig holes. So in the softer soils, we're going to want a more aggressive tire, which is going to be a tire with what this one is, an R4 pattern, and it's got more lug to void ratio. So there's more void, more space in between the lugs to give you grip. That'll allow you to go ahead and travel in that soil, give you the grip, and not get stuck as much. So a good choice is R4. Oh, Mr. Khan asked a great question. How much percentage variation over recommendation inflation pressure is acceptable? That's a great question. The proper engineering answer is 0. The other answer is never exceed the maximum amount of inflation pressure that the data calls for. So if your tire has a max inflation pressure of, let's say, 60, that's what it can handle, and that's the load it can carry at the speed it's designed to travel. So going over is really not recommended. Now, if your max inflation pressure is 60 and your load and your speed requires 40, then you can go to 50 or 60. What you're going to have to understand is when you do that, especially on a radial tire, Mr. Khan, is your contact patch is going to decrease when you increase that air pressure. When you decrease your contact patch, that's the amount of face of the tire, the amount of tread that's coming into contact with the surface, it's going to scrub more. It's going to wear off more rapidly. As it wears, you're going to decrease that tire's life. You're okay to do it. You're perfectly legal to do it, but that's what's going to happen. The other thing that's going to happen is the ride comfort for your operator is going to decrease. Because in all these machines, the tire is part of the suspension. So if we've got too hard of a tire, too much inflation pressure, we're going to have a rougher ride. If we have too low of an inflation pressure, we're going to have more of a sloppy ride. So be careful to find that happy medium. I think what I'm trying to see is you want a good safety spot where I need 40, but 50 is okay. As long as we're not exceeding maximum amount of inflation pressure, we're great. As long as we're not below what the inflation pressure is for the load and the speed that we're carrying, we're in good shape. I hope that answers the question. If you'd comment back on the question and answer session, if I did a good job, please let me know and I can get into it further. So next, right application. We're back to the same machine, but now we're going to be on a hard surface. This is something more of like a Department of Transportation or a city or county backhoe would be doing. We're going to be on concrete and asphalt most of the time, soft soils, maybe once in a while. So again, we're looking at that compromise. We want the best amount of traction we can have, but we want a longer lasting tire. So that's where something like MS907 R4 tire comes in handy. This has got less lug to void ratio. So there's a lot more lug on the traction or the face of the tire than there is space between those lugs for grip. So that tire is going to be more of a hard surface tire to operate in those construction zones and on that hard surface. Any questions about the difference between a more traction tire and a more hard surface tire? Okay. How about tracks? Got to tell you guys, sometimes a tire is not the best thing for the application. Now, in this particular application, especially when we're talking about backhoes, skid steers, telehandlers, loaders now, we simply can't change from a tire to a track because we just don't have the equipment. But sometimes we have to look at the equipment and our operation to pick the right thing. So I really like tracks in landscaping opportunities, in asphalt applications, and in road building applications. You've got a really nice long contact patch, which means you're going to spread out your compaction. That's really important in landscaping. The person you're dragging the rock into the backyard, if you're using a little loader like this, is going to appreciate the fact that his grass can actually root down, and so can his plants. On the asphalt and hard surface side of it, you're going to scrub less. So that track should last you a fairly long time when it comes to those sort of construction sites on concrete and asphalt. So occasionally the tire's not the best option, the track is. Any questions on that? Oh, and by the way, Maxim Tire North America will be supplying tracks to the North American market starting right now. So if you have interest, contact your local Maxim dealer. We'll be happy to show you what sizes and what our opportunities are for you. Seasonal maintenance. Living in Colorado, having Wyoming, Kansas, all the way up north. Guess what we have? Some people call it winter. And then we have something that's called summer. And in between, we have all of those temperature and weather differences. So what does that mean for our tires? Well, could mean the tire we've got on isn't the tire we need. Maybe we need more of a snow tire. Maybe we need to really check our pressures and to make sure we know what we're doing during the seasons. So in between those seasons, especially when things cool off, that's the prime time to look at our air pressures and make sure we're matching up with our speed and our loads. So the way I really want you guys to do this is to investigate the tire fully when you're going into your next season or your next operation. So start at the bead and the rim. Look at that bead all the way around in the circle. If anything's tucked under, anything looks like it's chunking out, anything looks like it's bent on the rim, might be time to call a professional and see what's going on. We may need a new rim. We may have already damaged our bead. Check the valves, the stems, the cores, especially check the caps. You go out and buy a little bottle at Target and put some Dawn dish soap in it and a little bit of water. And when you're checking your tires, spray the valve stems, spray the caps, spray the cores. If you have any little bubbles, you've got an air leak. It's time to get those replaced, especially the cap. Everybody understands the core is there. That puts air in. The valve stem is there. That's what allows you to put air in and out. The cap is what actually is holding the air in the tire. So make sure you have a good solid cap. Make sure you've got a good rubber gasket on that cap to keep that air in the tire. Moving up from there, check the sidewall. Look for major cracking. You're always going to have a little bit of spider cracking from ozone and weather. But if you've got a crack that's going circumferentially around the tire, might want to call somebody. We could have a low inflation pressure issue and we're having problems with that sidewall. While you're inspecting that sidewall, look for bubbles on the sidewall. They can be the size of a marble up to the size of your fist. If you have that, that means we've had an impact damage on the tire, or we've got bead damage on the tire, and we've got air escaping and finding that small hole and going into the sidewall and bubbling it out. That's a dangerous thing to have. Make sure you're looking for those bubbles. Make sure you're looking for cracks bigger than just weather and spider cracking. Look at the face of the tire. Check the tread out. Look for how the lug is attaching to and still attached to the face of the tire. Look for cracks around it. Look for chunks coming out of the lug. Look for bubbles. Look for anything that might look like an impact. If you can, pop it up, put it in neutral, spin it around a little bit. Great time to look for metal objects and tires. If you see a nail, you see a screw, you take it out, time to get it repaired. It's a lot easier to do those repairs while the machine is stationary and out of the job site than it is while it's in the job site. So all of this is about saving downtime, keeping your operators safe. It's better for you to replace or repair a tire when it's off the job site, somebody can really get to it easily, than it is to have somebody come onto the job site or try and take these tires off and get them replaced. So a little bit about preseason maintenance and common breakdown. Again, every time you're changing a job, you're changing a season, you're changing an operation, take a few minutes and check out the tires. Look at everything we just talked about. Teach your operators not to spin the tires when they're trying to move things around. Spinning creates heat. Heat really hurts tires. And the cooler we keep our tires running, the longer they're going to last. One thing I tell operations all the time is to be really careful of water. Water's deadly. It hides objects. And water really acts as a lubricant on the tire and increases cutting. So while you are going through water, if you hit rebar, your potential to cut that tire is just increased. If you hit a metal sign, your potential to cut that tire has just increased. If you hit a rock sticking up out of something, your potential to cut that tire has just increased. So Mr. Khan asked another question, which was, do skid steer tires have tread wear indicators? So that really depends on the brand of the tire and who designed it. Some may, some not. So really reach out to the manufacturer of the particular brand that you have and ask them if they've got a wear indicator on the tire. Now, I know for Maxim, some do, some don't. So it depends on which one you're talking about. But really, if you're going to measure a tire, measure the center line tread of the tire is where I do it with my indicator to see what I've got. The data will tell you how many 30 seconds or how many millimeters of tread that you start with. You can start subtracting from there to see how your tire is doing. So if I explain the puddles really well, that's one thing that I've always had problems with is people driving through water. I'm guilty of it myself. I like going up in the mountains, got my pickup, I see a puddle, I'm elk hunting, I pretty much go through it anyway. And even on truck tires, loader tires, everything else, you will end up cutting those tires when you drive through puddles. So teach your guys to be really careful around those things. Anytime you can get water away from your job site so you can actually see what you're driving over is the best thing possible. So again, we're talking about extending tire life. Maintain a clean area on the job site if you can. Don't run over signs. Don't run over logs. Don't run over tools. Don't run over each other. That's usually a good safety thing that I like to tell people. Maintain your tire pressure. Do it first thing in the morning. When you get to the job site, check it. If it was 40 yesterday and it's 35 now, you've lost air for a reason. It's just not magic that it disappears. We could have a hole in the tire. We could need to get it repaired. We could have a valve stem that's simply bent. We could have a cap that came off and we just lost a little bit of air. Slow down. Excessive speed builds up heat. Heat's not the friend of tires. When we drive the right speed for the tire that we have, for the machine that we have, for the load that we're carrying, everything works out well. So make sure if the tire is an A2 tire, it's a 5-mile-an-hour tire, that's our max speed. If it's a A8 tire, that's a 25-mile-an-hour tire. That's our max speed. Make sure you're matching your load with your air inflation pressure and your speed. All of those need to line up. Avoid spinning. Avoid puddles. Try and make sure if somebody is diving into a pile and really spinning, they're learning to lift that bucket and fill the bucket with energy as opposed to spinning the tire. Once you start spinning, that energy's got to go somewhere. And that's where you end up with high heat, you end up with tires spinning on the rim, or you end up with simply excessive wear on a tire that could have lasted longer. Pre-shift checks. Again, check your tire pressure. Make sure the valve stem's in good shape. Look at the valve core. Look at the cap. If you're missing a cap, replace it. Check the bead. Make sure that nothing's bent under. Make sure the rim is in good shape. Make sure there's no cracks there. Check the tread. Look for holes. Look for things sticking out. Look for anything that's odd. If it's metal and shiny and sticking up, it probably shouldn't be there. And it's time to get that particular thing removed. Some things to avoid. Now, every machine has to back up, but we don't want to back up too far. It's better to be moving forward than backing up on some tread patterns. You take an R4, for example. Once you back up, you're defeating the design of the tire to keep going forward. You're going to increase the scrub and you're going to increase the amount of wear on that tire. Avoid spinning, erratic movements. How many times have you hit a job site and you've saw a skid steer doing this? Somebody's having a good time, but they're wearing out tires. Route out your best driving path. Look at the operation you're in, figure out what the route should be. Keep people off that route so they're not dropping tools, they're not dropping rakes, they're not dropping other debris, so we're not having the chance to run over anything. Look at your slopes. Look if we're going up and down, if we're coming across. Minimize those as much as possible so we keep that operator safe, we avoid slides, we avoid any damage. Please coach your operators to go around obstacles. Through is not always the best thing. Teach them to look where they're going. How are we going to operate this machine? Where are we going to go? Why is driving over the big rock patch a bad idea? Okay. Get references. We've put together multiple air and pressure visual guides to ensure the site safety and to ensure the best amount of time you get with your tire for the amount you're paying for it. So take a look, call and get the information. You can always call Maxim's 800 number, get some technical information, or just reach out to your dealer and ask for the load inflation pressures, ask what you need to be doing to improve the life of your tire and hopefully your operation. So in summary, check proper inflation pressure. Match the speed of your machine, the load that you're carrying, with the inflation pressure you need to carry that load. Don't exceed the manufacturer's recommendation on speed and load. Don't exceed the manufacturer's recommendation on air inflation pressure. Pick the right tire for the right application. Again, everything is a compromise. Sometimes we're going to be in soil. Sometimes we're going to be on hard surface. What are we going to be doing 75% of the time? Do I need a pneumatic tire? Do I need a solid tire? Am I in a metal recycling application where a solid tire is going to be the best that I can have for my operation? Avoid hazards, especially puddles. Can't emphasize that enough. If we're out of water, we're going to be out of danger. Water hides everything. Unless you're on a clear spring in the mountains, it's going to be muddy. There's going to be rocks. There's going to be metal. There's going to be tree roots. There's going to be something there that will cut that tire. The moment we cut the tire, it can't heal. It is going to continue to wear with that cut on it, and it's just simply going to get worse. Operator training. If you don't want to do it, please give Maxim a call. Call your tire dealer. Call the manufacturer of your preferred tires. See if they'll come out and help with your operators. Coach them on the proper way to investigate a tire, how to look at it in the morning, how to take a proper air inflation pressure. Make sure that your tire gauges have been calibrated. You really need one on site if it's right. If you're within a couple percent, you're going to be okay. But what you don't want to have is a tire gauge reading 80 when it's really 100 or 60. If it's 80 and it's reading 78, you're going to be okay. Do your pre-shift daily. You're checking gas, you're checking oil, you're checking grease. Make sure they're checking the tires, the rims. It's all about their safety. We want to make sure they're home at night. Coming back the next day and doing it all over again. So that's pretty much what I've got. I appreciate the time. Any other questions? Mr. Kahn, you've had a couple. Anybody else out there have anything that they need to ask?
We do have a couple, and remember, you can continue to ask questions and we will answer them until we run out of time. So one question that's come in is, when should I select bias, radial, or solid tires?
Oh. Wow, that's always a great question. Let's just start with solid tires. So solid tires are wonderful if you're in an area where you know you're going to have excessive flats. So solid tires go great in concrete recycling areas. They go really good in transfer stations for trash, metal recycling, anything where you know you have there is no way to avoid picking things up out of tires. So the worst thing that's going to happen to a solid tire is the screw's going to go in it and you're not going to go flat. That's perfect. The issues with solid tires is they can't go on soft soil. You're going to sink. There is no give. There is no air to help with the suspension. The ride is not going to be as good as a pneumatic tire. So you're going to have to, again, have some compromises as to what the machine is doing and what you need it to do. So make sure that if you're going to use a solid tire, it's going to be mostly on really hard surfaces. You're going into an area where you've got to have a tire last. So metal recycling, things like that. Solid tire is really good. Asphalt applications, a solid tire is really good. I see Mr. Thompson had a really good question, which was, can you speak the basic differences for L4 and L5 besides tread depth? Yeah, that's a wonderful question. So when you're talking about L3, L4, and L5, you're really talking about loader tires. And an L3 and an L4, in most cases, are going to have the same casings or the same casing dimensions, and your tread's going to be deeper. So that's the difference there. The difference with an L5 is you've got really super tread depth. But an L5 tire has got a smaller volume casing to it than an L4 tire does. The reason why that is an L5 tire has to have the same overall dimensions as an L4 or an L5. Okay? So if you're looking at, let's say, a 20.5-25, and you've got an L3 and an L4, that overall dimension is the same. Difference is tread depth, because it's about 25%. The difference on the L5 is we're going way up on tread depth and protection of that tire. So the casing, the volume of the casing has to be smaller. So you've got more tread, smaller casing, and you have less air in that tire. Your pressure is the same because PSI is measured in volume, but the chamber is different. So if the chamber is different, we carry less air. That's why with an L4, you can travel a little bit faster, a little longer than you can with an L5. L5s are set up to go, 500-600 feet. You're usually at an area of a quarry at a wall. The tread depth's a lot higher, but the chamber to hold the volume of air is less. Mr. Thompson, does that answer your question? I can't hear him, so
Right. While we wait for
I'll assume
him
it.
to respond.
So back to the bias radial solid question. Bias tires, where I really like to have bias tires, is in an area where somebody says, "Hey, I have to foam fill." Wow. Okay. Lots of questions coming in. So bias tires, I like to have a foam fill. They're kind of the original design for loader tires, and how they're gonna react. Bias tires, they are less expensive. They do flex differently. They give you a little bit different ride. But when a bias tire gets a load underneath it, it does more of an oval shape as opposed to a rectangular shape like a radial. So you're gonna have more wear on a bias tire. You might have a little bit more protection, because what a bias tire used to be is when you had a 16 ply tire, is from bead to bead, it would wrap like Band-Aids and you would have 16 plies. Now it's not necessarily that way. You have a bias tire that's 16 plies, but there may only be 8 plies, but it carries the load of 16 plies. So it's more of a load carrying reference than it is how much is actually there. Okay. So I'm going to go into these questions real quick. Mr. Khan asked, is there any thumb rule for tread depth relationship between L3, L4, and L5? Yes, there is. You're going to take me back to tire 101. So L3 is kind of your 100%. When you're looking at your L4 tread depth, you're kind of about that 125%. And then when you're getting to the L5, think about 150%. So once you get above that 125, that's why you have to make adjustments to the casing. So you're getting that extra tread depth. So I hope that helps, Mr. Khan. The next question was from Mr. Thompson. Any application reference or example of choosing a radial L5 versus a bias L5? So my thoughts on this, a lot of it is personal opinion. There are loaders out there in some quarry and mine applications where they really like having a bias front tire because it can be stiffer. And the personal application is, I feel safer with the bias ply because there's not as much give. There's not as much sway with that load left and right. They'll still have a radial rear tire and a bias front. Some folks, completely opposite. They like having radial. Some folks' personal is bias. I think it's kind of a mix of personal. I prefer the radial product, but again, it comes down to the operation and the teaching of load that we're carrying, the speed that we're carrying it, and the pressure that we're going to try and maintain. A lot of problems I've seen with, I want the bias on front, I want the radial on back, it has to mix with chains, it has to mix with that personal preference. It's okay to do. You're not going to hurt anything. But if you're going to do it, again, you've just got to maintain that pressure. And most of the time, a bias tire is going to be stiffer, and you probably won't feel that same left or right sway. I hope that answers that question as well. Okay.
So I actually have a question,
Sure.
if you don't mind. So you said there's a chart for speed of the tire along with the load. So is there a best practice for if throughout the operation of the day, you know that your load has changed significantly?
So if you know your load is going to change significantly, if it's going to go down, leave it as is until the next day. Then you can adjust your inflation pressure. And most of that is going to be for ride. Okay. You're going to have less bounce. If it's going to go up during the day and you know it's going to go up during the day, predict that in the morning and put your cold inflation pressure at what you think the load is going to be at 2 p.m. Because at that point, you're still building up the heat. You're still going to have more pressure than what the load is going to be at that day, but you're going to have the right inflation pressure during the day for that load. Does that help? Does that make sense?
Yes.
Okay. So Mr. Thompson asked another great question. Radials will dissipate heat better, correct? Yes. Radials are going to dissipate heat better because you're going to have just a single radial casing. So radial casing is the wires of the casing go around the bead, up and over. So they're just doing this. We're bias ply, we're laying things on top. So we've got more material that we have to go through on a bias ply. So a radial tire should dissipate heat better than a bias ply tire. Now, I know for a fact, Mr. Thompson, if you put on a solid tire, it doesn't dissipate heat. So, make sure that application, if you're ever thinking about a solid tire, please, 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 if you're thinking about a solid tire, think about 250 feet to 500 feet of movement. That's it. All right. We're not taking that thing and running it down the road to go grab something and running it back. But a radial tire will dissipate heat better than any other tire, to my knowledge. Absolutely. Absolutely. So a little bit on the finish of why choose radial, bias, or solid. A radial tire, when it's inflated properly, is going to give you a square footprint. So that's going to give you a lot of wearability. It's going to wear evenly across the face of the tire from center, center, front, and back, side to side. It's going to wear down more evenly. For the ride, it's going to give you a much better ride comfort for your operator, usually on a radial tire. That's part of the reason we've gone to radial tires on all our commercial trucks, on these large 63-inch, 51-inch, 49-inch trucks that are up in the coal mines and the gold mines. Those are all radial tires. We want to make sure that ride comfort's there. The wear is always much better on a radial tire just because of how it wears. Compaction, if you're worried about compaction in an area, that's big on a radial tire as well because of that square footprint. Okay. We want to do something on ag tires later. That's the reason why even ag tires have been radialized, because we're getting that long footprint like we would a track that reduces the compaction, which increases our root development, which allows us for better food production. So really, when you're looking at the differences, it's part of your operation. What can we handle? What can't we handle? So a solid tire, we're going into something where we know we're going to have flats. It's going to happen. A bias tire, we're cost effective. We are looking for something that we don't have to spend as much. We know it's going to last. We know this is the 20-year-old skid steer that's just in the yard. We don't need something that major. We go to a radial tire when we know we're going to be doing something that requires more traction, requires a longer life of the tire. It's certainly our primary machine that our operator is going to be in, or yourself is going to be in. You want more operator comfort. You want to have something that's going to really last, really do the job, give you the most traction, give you the highest benefit of that tire in that application. So that was a really long way around to answer that question. But how did I do? Did I answer the question? Or?
You did. And I am not seeing any other questions in. So I think that wraps us up. Michael, thank you so much for this great presentation and for being here with us today. We really appreciate it.
Well, I really appreciate everybody for attending. Again, thank you for having Maxim Tire on. We love questions. We love our clients, and we want to make sure that they have the best experience possible with Maxim. So if they ever need to reach out, please, maximtire.com, or contact your local dealer.
Awesome. Attendees, again, like Michael said, we appreciate your attention and your time. Please remember to check out the related content that the team shared. Lots of great information there. Thanks for joining us, and we look forward to seeing you for our next webinar.